In this particular video, I'm going to show you how we can design an API that is fast, scalable, secure, and easy to use. Additionally, on the top of that, I will show you the 9 best practices that you need to follow while designing such an API. To make things complete, we will actually go ahead and build an application using Node.js and Express so that we can see and implement all these best practices in real life. I'm so excited to get started. Hey everyone, it is Avi this side. If you are new to this channel or watching my videos for the very first time, I highly recommend you to go ahead and check out my channel. We talk about tutorials, concepts, careers in software development industry, and also about the new trends that are going on. If you like the videos, then go ahead and subscribe to my channel and let's come back to the topic of REST APIs now. So REST APIs are actually a particular type of APIs. Now I'm assuming you understand what APIs are. API stands for Application Programming Interface. And REST APIs today are one of the most popular kind of web services out there. They conform to the specific architectural constraints of the REST architecture. Now these include things like statelessness or catchability, and we will talk more about that, so stick till the end of the video. But what we want to mention right now is how we should design our REST APIs so that they're actually secure, scalable, and easy to use. So these are the 3 things that we want to focus on: security, scalability, and ease of use. Now what happens if I don't make my APIs, or I don't design my APIs in such a way that all these things are actually being taken care of? So first of all, if my API is a public API, so let's say it's one of the APIs that actually I have put out for use, or it serves a particular functionality, or maybe I have my own social media platform and I have released my APIs for public use, then the very first thing that will happen is people will get very confused about how to use my API, or how they can actually extract data or do certain functionality that is mentioned in the documentation. So designing APIs that way and maintaining the standard of the APIs is very important. Secondly, if you have a set of maintainers, if your API is actually huge, then you will definitely have maintainers who are maintaining that particular project. And if you design your APIs in a bad way, the maintenance will run into nightmares. They won't be able to solve issues. So these are the 2 things that will repeatedly happen, and you have to ensure that they don't. So that's why we need to maintain the best practices while designing our APIs. Now let's not talk more about this, but let's straight away dive into the 9 best practices that you should take care of while designing your APIs. Alright, so let's go ahead and look at all of those best practices I have been talking about. So in this lecture notes, I have mentioned all those 9 best practices which you must follow while designing your APIs. So for each of these, we'll actually discuss what exactly we need to do, and then go ahead and implement the same thing, the corresponding thing, in terms of code. So we are starting with the first point, which is accept and respond with JSON. Now JSON itself stands for JavaScript Object Notation, which is a lightweight format for storing and transporting data. Now I'm sure you must have come across JSON before. Now JSON is very popular. It has actually sort of changed the way in which we see data in terms of key value pairs, essentially. And many of the very common databases, let's say we have the NoSQL database MongoDB, which is sort of based on a derivative or a superset of JSON known as binary JSON. So I just wanted to emphasize on the fact that JSON itself has become very popular. Now coming to this particular point, what I want you to do is, whenever you have your server side and your client side, and they're actually trying to communicate with each other, or maybe we are trying to communicate between 2 layers between these 2 endpoints, we actually want to ensure that those data or those responses or those requests which I am sending or receiving, they should actually be in preferably be in JSON format. Now JSON is not the only possible format. Of course, we had XML before that, and XML right now is not very widely supported by most of the frameworks, but JSON is really the standard out there. And we also have form data. Now form data is good for sending and receiving files, but if you're dealing with key value pairs, JSON is the one you should go with. Now let's go ahead and look at the code. So I have a GitHub repository, I'll show you that, but also we should go ahead and start working on writing the first few lines of code. Before we go ahead and start writing the first few lines of code, I would like to show you the repository that we'll be using. And this is basically a generic repository I have made for all these smaller fundamentals in which I'll be building small apps. So if we are building some application which is big and it is sort of a specific application or a specific tech stack, then we will have a separate repository for that. Anyways, for this particular repository, I'll be sharing the link in the description below, so you can go ahead and check that out. But what we have here is you can head into the REST API best practices folder, and inside here you will find this PDF. That is the one we are referring to right now. But if you look at the Express application, that is where you'll find the entire code. So I'll be explaining the code of whatever we have and whatever we will write. And here is actually the repository structure and some of the resources which I'll be referring to throughout this video. So you can go ahead and check it out as well. All right. So let's move on to VS Code now. And inside VS Code, what we will do is we have our Express application, and we do have a few folders already here. So I have taken the liberty of installing Node modules. How you can do that by simply writing npm install in this particular folder. And since we already have the package JSON given to you, so npm install will do the job for you. Okay. So in the repository, the app.js file actually contains code for the Express application, and that we'll be writing right now. So we can start with that, let's say. So first of all, we'll begin with the obvious. I'll go ahead and require Express. So I'll say constant Express is equal to require Express. And below that, I'll actually then require Morgan. So for those of you who are not aware of this, Morgan actually is a logger. So basically whatever requests we send or whatever responses we get, the status codes and all that. So it's good that we have Morgan in so that we can actually have a look at what is happening as we send our request. Now FS stands for file system. I'll tell you in a minute why I am actually importing this one. And then we can actually say that our application is equal to Express. Okay, so let's save this up and the auto format worked. Let's now look at database.json, which is actually a JSON file with 1000 entries of 1000 users. And for each user, we have a particular ID, which is basically the count number. We have their first and last names, and we also have their email and gender. Now, what you're trying to do here is I'm trying to use this as a file database. And I didn't want to connect to an actual database like MongoDB for a very small demonstration. So I'm going to add and remove data from here, and that is the very reason why I made use of file system module in the first place. So now let's go ahead and add a few middlewares. So I think you guessed the first one, and we have already imported it. It's Morgan. So I'll say app.use and I'll say Morgan. And in here, I'll specify the type. Basically, I'll say a dev. So there are different formats here. I prefer the dev format for Morgan and the way in which it, logs the data. And the next thing we'll use is express.json. Now, why do we want to make use of express.json is that this serves the same purpose as body parser. And express.json will just help you read the request body, and which is basically hoping that the request body will be in JSON format, and it will try to then pass that. We'll come across its usage later on, but let's now go ahead and add our first route. So this is where we get to see the or basically see in real life the point we were talking about. So my first route will actually be users, and when I say users, I'll go ahead and add a callback here, and by default it's request response, and then I go ahead and send back something. So in here I'll do a simple thing. I'll just send a response with a status code of 200, and then I'll go ahead and maybe send a JSON data back. So I yet don't have any data to send back. I also shortly fetch data from the file system using this database.json that we have been talking about. But for now, let me send a message that just says that hey, this is working. So that's it, and after that we need to basically take care of the server. So what I will say is basically server, and then app.listen and 3000, and then I'll have to add a callback which will just say that uh, console.log server is running. Okay. So if I go ahead and start my server basically, so that I can do by saying npm start, and this will go ahead and run Node.js, which I've already installed in my system globally. So if you haven't done that before, I think it will still work for you because Node.js might be here. Okay, Node.js is not here. So I recommend you to install Node.js into your system. That would be very easy. You can say npm i Node.js and it will install Node.js globally. You must mention the -g flag to install it globally. Or you can add it into the dev dependencies if you don't want to install Node.js, but I think Node.js is a good thing to have installed globally. Okay, so now since the server is running, I already see the server is running here, and I can go to my Postman. So I already have created a particular collection for this project, but what I'll do is I'll tell you open a new one, and in here I say localhost 3000, and it's just users for me this time. So if I send a request to this one, I get request. So I get my message that says, "Hey, this is working." So basically, we are able to get a response from our server now. Now let's go back and actually get back to VS Code. And in VS Code, what we'll do is before this route, let's go ahead and make use of the file system import that we had, and I'll say constant users, which will store basically all the users, and I'll use json.parse to parse the JSON data that I'll get back, and I'll say fs.read file sync. Now, let me know in the comments why do you think I made use of read file sync and not read file. I think it's a very interesting question, and I'm really happy to see some of you answering it. So let me know down in the comments why I made use of read file sync here. Now, the easy thing what I'm doing here is to just get the file name, that is database.json. So that saves the users. And what I want to do here is I want to send back a JSON response, as I have already mentioned before. And the JSON response will follow a format called JSend. Now, JSend is a format in which we specify the status for the particular response, and the status here is actually success. The other alternatives are fail or basically empty, and you have to choose one of these status codes based on. So it's not a status code; it's a status message based on what exactly you want to send back to the user. Now, in this particular scenario, since I have multiple responses, I also will specify additional thing known as results, which will contain the number of responses I have basically. So users.length, I expect this to be 1000, and finally I have my data. So this is another thing in the JSON specification where we actually send back data and in the form of an object, and that should again have the key as whatever object is representing. So in my case it's users, so it will be users, or if you have the ES6 notation, I think we can just keep it users like this. Okay, so if I save this now, this should be working. I'll go back to Postman and send the request again, and yeah, you see that I have got a status of success and 1000 results here. And in the JSON format, you can see that the format is by default JSON here, and I have got a JSON response which is very good, and I have received a response for each and every user here from 1 to 1000. Now, are you sure this is a good practice that we send back all the responses, all the users? We'll look at that later on in this particular video. Okay, let's move on to the next best practice now. So next in the list, we actually have use nouns instead of verbs in endpoint paths. Now, for each and every resource that we have here, we actually try to specify some paths corresponding to that resource. Let's say we had users, or we are trying to add some functionality to users. So corresponding to that, we'll have some endpoints. And now these endpoints should actually have nouns instead of verbs in their nomenclature. And by that, what I mean is like you should be using very specific names which actually represent the name of that particular resource. And we should not add verbs like, retrieve users or fetch users, or get all users with particular name xyz things. So that will make your get request, or maybe let's say any request for that matter, very long, unnecessarily wrong. And also it might be very difficult to understand what you're trying to do, because different users or different developers have different way of mentioning things. For example, get may be mentioned as retrieve or as fetch. That's depending on the developers basically choices. So now we have HTTP request methods, basically the get, post, put, delete, and we also have patch, which is very common. But these together will form the CRUD, which is also called CRUD, and it stands for create, read, update, and delete. And these HTTP request methods already have the particular verb, so we do not need to add verbs to our endpoint paths. Now, secondly, we need to name our collections with plural nouns. So even if I'm talking about all the users, I should be saying slash users. Or if I'm talking about one particular user, I can say slash user slash the user ID, and that will fetch the particular user ID. Now, it's actually a convention to use plural nouns, and that's what we'll follow. This is an example of what I've been talking so far. So instead of using slash get blog as the endpoint, we should use slash blog slash id. So when I'm saying get blog, I obviously am referring to a particular blog. So you can go ahead and mention that particular id for that blog. Now, given this endpoint and given this particular method, or the HTTP method that we have, which is get, I can clearly understand that I am trying to make a get request here. So this get here is sort of rendered unnecessary. Now, similarly, we have create new blog, and you can make use of post for that. Update can use either put or patch, and you have to specify the IDs. And similarly, delete blog can also make use of delete, and we can specify the IDs. Now let's go ahead and see this all in code. In fact, we'll be writing quite a bit of code now, and we'll be implementing all these CRUD operations on the particular data that we have. Let's get started with that now. Okay. So now we have to go ahead and actually implement the post, the put, and the delete methods. And what I'll do is I'll just make use of the same endpoint here. Now, what we have learned in our last point is that we want to ensure that our endpoints do not have any verbs. So instead of saying add user, what I will say is just users. And again, I'll just be copying this callback function from here so that I don't have to write things up again. There we go. Okay. So before this though, like before we send a response, what we want to do is we want to add a new entry to our users that we have here. So this users is reading all the data from our JSON database. But what we want to do is we want to actually look at the payload that we are getting from our request. Now this is where this middleware express.json comes into use. I told you that we'll have a look at it earlier, and this is where it will come to use. And I'll be actually passing the request.body, and I'll try to understand what data is in here, and I'll try to update these users accordingly, and then I'll send back a response. So first of all, what I'll do is I'll specify a new ID. Now, when we have a post request like this, it is usually customary that the ID is generated on the server side. So if you have a database, let's say like MongoDB, then in that particular case, this is generated automatically. But here what we will do is I'll just have a look at the ID of the previous entry. So when I go for users, I have users.length -1, which is the last entry, and I'll just add one to that, and I'll store that as my new ID. And what I can do is next thing is constant user. So I'll take whatever user data that I have from request body. So here I'll be using a ES6 syntax, which is also called the spread operator. So I'll spread the request dot body thing here. Let me explain what we are trying to do here. So instead of me making use of request.body and trying to accept the ID from request.body, since it is a custom, we are generating our new ID on the server side, and I am actually creating a merged object, which is adding a new property of this one to the request body. Now, some of you might argue that I want to add ID here inside request body, but I don't want to mutate the body that is coming to me. Instead, I want to create a new variable that stores this. So this is something which you can do. And after this, the next thing that you should do is actually fairly simple. You can say users.push, and since that was a array which we had above, basically a list. So user.push will then add the new item user. All right. So that is done. Finally, you can say fs.write file sync. Now, should I use a write file sync here? No, I should be using a write file. That is because I don't want to block the event loop. Now, I asked you a question like this before, and I think this is a good hint for that. And I'll be using write file here because I want to make sure that my event loop, which is here, should not be blocked. So I'll actually go ahead and use the asynchronous version of that. Now I'll copy the file name from here because it's the same thing, which is database.json, and I'll paste it here. Okay, and what I want to do is in the next thing I want to add the data. So I'll add the data here, but before that I'll stringify it. So JSON.stringify sort of converts the JavaScript object to a JSON format, and in this case the object that I have is my users, which is basically an array of objects. And finally, I'll add a callback here. So the callback here has, let's say, error parameter, and there's this function. So inside this, I want to make use of this particular function now. Okay. So I paste it here, and I think we have times. Yeah. So now the status code that we want is not 200, but should be 201, which signifies that a new, object or a new data or a new entry has been created. And I want to send back JSON again, but this time instead of sending back JSON, what I will do is, okay, hold on. I think we may have missed something. Yeah. So instead of sending back JSON like this as we did before, I'll change the results because now we have only one entry, and the status still say it says success, but the data that I have is not going to be this. It's going to be user, and I can say user. So either that, or you can maybe call this a user according to you. And if you use the ES6 format, it will be just user. So I can save this now. That does the post part of my work. Let's go ahead and check it out in Postman now. So if I move on to Postman, I have a post request here that has this endpoint, and in body I have already prepared the body for you. So you can specify the first name, the last name, the email, and the gender. So basically everything other than the ID. Now, if I go ahead and send a request, so I see that I get back a response, which is exactly what I have just put. So it says the status of success, and in the data I have a user, which is basically the new user that has gotten created. And I have an ID of 1001, I have my name, my last name, and whatever payload I had here, basically the same thing. So the interesting thing happens when I go back to here and I open my database.json and let me format this. And once you have this formatted, you get to the last entry, and yeah, you see that a new entry has been created in this file. So that is basically the thing that emulates a database. So my post request is actually going to create a new entry here, and that is what we wanted to do. And all this we did using a particular endpoint which had noun instead of verbs, and also we ensured that it was plural in nature. So let's move on and add endpoints for put and basically delete. Now I won't be implementing these per se. So I'll be just explaining things to you, and because I don't want to keep writing those file system based codes. But here I'll have to specify a particular ID, because when I'm updating something, I need to know what particular entry I'm going to update. So it will be a request response again, the callback, and inside here, what we can say is response.status, and this will again be 200, so which signifies success. And here I'll send back a JSON response, and inside JSON response I'll say status, sorry, not as a string but as a JavaScript key. So the status will be success again, and I can send back some data to the user. So ideally what I should send back is whatever user I have modified, and I don't want to modify that in the file system, so I'll just say something like updated user info. So this thing works. So maybe not this, I think that's an extension that just worked. I just want to keep a string here. Okay, so that works, and that is how you can create a endpoint for put. Similarly, you can also go ahead and create an endpoint for delete, and you can paste this here. So I'll just remove that. Yeah, so instead of put, I'll say delete. And the only difference that you can have here is that instead of you saying success and data as this, you have to change the status code to 204, which basically signifies not found. And you can change this to null. So this will signify that you actually deleted the particular resource in the database. So that's what you have. Now, one thing you must have observed is that I have mentioned ID in this format. So whenever I have this in Express, it means I can actually read this parameter from the URL. So how we do that is basically by going ahead and saying, okay, caps on, going ahead and saying constant ID equals basically params request dot params. So this will fetch all the params, and I have used object destructuring. So I'm going to get my particular ID from whatever ID I specify. So if you want, we can even log this just for checking it. So we can say console of log ID, and I can save this now. Alright, so all these things you're seeing here is actually my server getting restarted again and again on each save, because that's what NodeMon does. And since I have saved things now, let's go back to Postman and check it out. So in put, I actually have this one. So I have a put request that I am sending, and my user ID is basically 20. So if I send this request, then I get a status of success, which I had specified back there, and I get a user updated info, which actually should contain your updated user info if you're working in real life. And in this case, I have just put a dummy there. And similarly, you can delete a user. Again, we're not deleting anything per se, but if I send this request here, then I don't get anything here, but I do get 204 no content, which shows that the server is not going to return any content, and which is a significance that you have actually deleted a particular resource. So that is the idea of this. Now I have mentioned a console.log here, and you see that I have printed 20 in my console, which corresponds to the ID we specified back in Postman for the put request. So everything is working fine. Let's move on to the next set of rules that we have to follow, the next set of best practices. Alright, so next we have nesting resources for hierarchical objects. So I'll begin explaining this with an example. Let's say we have a blog, and each blog will have some properties. So if you look at this particular arrangement of data here, we do have an ID for a particular blog. We have a title, we have an author, and we have a set of comments. And I'm not sure if you're able to see it, but if I zoom in there, and maybe now you're able to have a look at that. But for each and every blog that I have, I do have an ID, title, author, and comments. And for each comment, I have again an ID, author, and a content for that particular comment. Now, this means that resources which are sort of related to one another, let's say in this case, my blogs and the comments, I can actually nest them together. Now, fetching those resources will be easy if I am trying to make use of a nested endpoint. By that I mean, let's say I want to fetch all the comments inside a particular article for a particular article. Then instead of having this in a separate database, if I have it like this, then this will be my corresponding get request, which is specifying an article ID and then finding all comments inside that article ID. So that is one other thing you can do, and this also sort of hides how information is maintained in a database. Now this is something you should not keep doing. Let's say we have a nesting level of 2 or 3, then it slightly starts getting difficult. In that particular case, I will highly recommend you actually have a separate database, or you change the way in you're storing data. And you should not be able to, or should not have to, basically send requests in which there is a level 2 or level 3 nesting. So it becomes highly cumbersome. Now, the next thing that we need to ensure is handling errors gracefully and returning standard error codes. Now, you must have observed that until now, even if I go back to VS Code, I'm always specifying status codes for each and every thing that I'm doing. Now, if I have an error, so every status code in the range of 200 is actually representing a success or a creation of a new data or something like that. But we do have a set of a range of status codes which represent variety of events. For example, if I go back to the slide, then I have let's say 400, which can represent a bad request, or 401, which is unauthorized, and 403, which is forbidden request. 404, I'm sure you have heard about this, is not found. So there are tons of status codes. I have a resource attached in the GitHub description, basically that explains all the status codes. You can check it out. And what we need to ensure that whenever you are trying to deal with different requests that we are getting, we must ensure that we are properly handling the possible scenarios of errors, and we are correspondingly sending back error requests, I mean error responses, which should involve a HTTP status code along with some error message. Now, this error message should be enough to give maintainers information, but should not have so much information that hackers can understand the working of our server side. So that is something you need to take care of. And finally, we have allowing filtering, sorting, and pagination. So in order to handle data, in order to make data manageable, in order to improve performance and make the API scalable, we must ensure that we are following these 3 practices. Now remember, recall that I told you if sending back all the information of all the users was a good idea. So that is where pagination comes into being, that you actually don't send data all at once, but you actually send pages of data, each page containing let's say a standard of 25 entries. So we want to return few results at a time. And if you want to filter data, if you want some data only, you don't want data of a particular type, so then you can filter those out, and you may want to reorder data based on a requirement. So these are 3 things that you can take care of. Now, before I go to 7, 8, and 9, I will implement all these in our current application that we have already up and running. So let's get started with that. So the first thing we'll do is to handle nested queries, basically. So I'll say app dot get, and this time instead of actually getting users, we will try and get all the users with a particular name, basically. So let's say I'll get all the user names with a particular ID. So I'll copy this one. Anyways, I think it's the same callback function. And in here, what I'll do is I'll specify slash users slash ID slash name. So you might draw a parallel to the blogs thing I was talking about earlier. That is pretty similar to what's happening here. And then what we have is actually some error here. Okay, we need to add this one. All right. So right now, instead of us sending all the users, we should send users for a particular ID. So how we'll do it is actually first of all fetching the ID. So that is like constant ID equals just what we did above, request.params. And below that we'll actually check first of all. So I want to check if an user exists for a given ID. So in that particular case, only in that particular case I'll be sending back a response. If a user does not exist, we'll be sending back error message. So how do I do that? It's simple JavaScript. I say constant user equals users dot find, and then what I'll do is I'll look for a particular element, and that element should be chosen whose ID is equal to the ID that I'm getting. Now this ID is actually a string, so this plus ID is a little hack here which converts a string to integer, and then I'm trying to see if that user exists. Now if that user does not exist, so this means that that ID is invalid. So in that particular case, I can just return a response, and I can send back a status of 404, and I can send a JSON that actually I should use .json. I can send back a JSON that actually says this, that I have a status of fail. Now I told you about this earlier, that we have another type of status message in JSON which is fail, and I just send a message here that explains what happened back here. So I'll say that you specified an invalid ID for me. So that is how it will work if there is no user. Now if there is a user though, I want that user name. So I'll say constant name is equal to users of ID dot first name, because remember we had first name and last name as two properties. So I'll just separate them by a space, and I'll call that as the total name. So again, I'll copy this here and I'll say first name plus space plus last name. So that is the username that we have. And now what I want to do now is I want to send back the username. How will you do this? We'll again remove results because we have only one result, and I'll just send back name here. So this is how I complete this particular thing. One more thing that we need to make sure is that I use ID -1 here, because my IDs are actually starting from 1, and the users of ID will actually start from 0. So that's one more thing that we have to ensure. Now going back here, let's say I have an ID of 1002. So if I send a request, then I get invalid ID because 1002 does not exist. But if I change this to 1001, if you remember, that's the person I created back a few moments ago using the post request. So yeah, I do get my own name. So I can change this to anything, let's say 200, and I can get something else, and that would be Nick. So for every user that is existing in the database, I am getting the corresponding name, and for every user that is not existing, I am able to handle the error. So, and also if you notice that if I add an invalid ID, I get a 404 not found here, which is exactly what I wanted to send back. So that following two great practices of sending back error messages and also handling errors basically, and as well as nesting resources whenever necessary. Now what we want to do next is actually implement the last thing, which is pagination and filtering and all those things. So for that, what I will do is I'll again create one more endpoint, and I'll be creating a get endpoint again, and this time it will go for users, and instead of fetching all the users, I want to fetch a particular set of users now. So it's the same request response cycle, the same request response callback function again. And inside here, first of all, what I need is, so I want to get back, the first name as well as the page number from the endpoint itself. So these are something called query parameters in your endpoint, which you'll be sending back. So I'll fetch them using request.query, and then I can go ahead and basically check if my page number is invalid. So if the page number is not basically truthy, so I'll set page number to 1 because that's the first page. So I'm assuming that my pages start with 1, and then I'll store the results of all the users inside this because I don't want to modify users in the process. So now what I want to do is for filtering, I'll be writing this particular few lines of code. What I'll say is if first name, if it's valid, if the first name is truthy, then I'll say results is actually equal to results. And this time I'll filter this. And so I'll do that using filter. And how will I filter it? I will filter using the first name basically. So what I can say is element such that element dot first name, and my first name should be equal to the first name that I have gotten. So triple equals and first name. And the next thing that I want is actually specifying a constant page size of, let's say, 25, which is signify basically how many entries will be in each page. And then what I can say is results will be equal to results, and this time I'll be using the slice function, and the slice function will just help me get all entries inside one particular page. So I'll say page number -1 into page size, and then the next entry will be page number into page size. So it will get me all those entries in the m-1 to m range sort of thing. And finally, I want to send back the response. And the response will be pretty much the same since I have modified the results. So I'll just copy this from where is that? From the get request. Yeah, this one. So if I go ahead and paste it here, since my results are modified, I also want back to send results and not users this time. So I'll say results, and also in results will be results.length. So we do have this results.length here, but now we have to actually sort of comment this one out because we'll have two routes with the same endpoints. And now I can save this, and let's go back to Postman and try out the first get all users endpoint now. Now, what I'll do is initially I won't specify any query parameters, and I'll just send this request. Now, what you can see is instead of 1,000 responses that we are getting previously, we now have 25 because that's the page size I want to specify. Now, let's say instead of getting the first page, I want a page number of 2, which means I want all the entries from the ID 26 to 50. So if I send this request, I get the next 25 responses. So this ensures that my API is actually performant and it's not held back because it's fetching all the resources from the database. Next thing, since we have added a filter based on first name, let's actually check all the entries whose first name actually is equal to AB. Now I have one entry which I have entered. So using the post request. So if I send this, I actually get one result and I have only one entry right now. But since it's up and running, if I can send this request again, I have created, let's say, 2 more entries. So if I send the get request again with the first name AB, I get 3 results now, and each of them have a different ID corresponding to the new entries that got created. So everything is fine back here and it's up and working. And we have seen all the previous things in action. Let's have a look at the last few best practices that you must follow, and we will come back here if needed. So next up we have maintaining good security practices. Now this is essential because whenever you are trying to send or receive sensitive data, you must ensure that you're actually the entire process is secure. So you can use SSL, which is socket security layer, or transport layer security, which is a sort of advanced version of SSL. And the good thing is that all of these are actually available, and you can add it to your your server for free or with some minimal cost. So I'll tell you how to do that in a minute. But what I'm trying to emphasize here is, other than SSL and TLS, you must ensure that your authorization, basically how much privilege you're allowing for the user, that should follow this principle of least privilege. So by that I mean, whenever the client is trying to send a particular request, whatever response you must give back to the client should not have anything more than whatever the client has asked. Now, this is subject to the fact that the client actually has an authorization to get that particular resource. And if he or she has the authorization, only then you should send whatever data that is exactly required to send. Nothing more, nothing less. So that ensures that you do not expose any unnecessary data to the client side. And also the admin should have a complete control over the data and the user, so that they can actually modify the roles or access for a particular user or a client. So that these are some of the good security practices which you can follow while designing your API. Next up, you can actually cache data to improve performance. Now, caching of data can be done in several ways, and one of the most common solutions is Redis, or we can also have API cache, which is a middleware. And again, I'll look at that in a minute. But caching will help you because you don't have to fetch data again and again from database, but you can actually query the local memory cache and return responses much faster. So Express has this API cache middleware which can add caching to our application without much configuration needed. And finally is versioning our APIs. Now, the last point is essential because you want to ensure that your API is actually when you modify them with time. Now, when you're working on a project that is huge, or you're actually maintaining the APIs for a particular functionality, you will be working on the APIs continuously, and you'll be having newer and newer or improved versions of your APIs. So usually, since you have published your API to the public, one set of public users should be using, will be using the version 1 which was previously available, and now you are making version 2 available. So you want to ensure that nothing breaks for the version 1 people. So you want to ensure that your endpoints don't look like slash users, but they actually do look like version 1 slash users or version 2 slash users. So if you're working on a new version of your API, then as long as your clients do not shift to the version 2, the version should keep working for them. That's the entire idea behind versioning our APIs. Now let's go back to our browser, and I'll show you a few things that we have spoken about. So this is a website that is again in the description, where you can understand what SSL, TLS, and HTTPS is. So you must have noticed these things. Even here you have this security thing that even prompts a show certificate thing. So what exactly is a certificate, and what exactly is a transport layer security? All these things you can have a look here. And certbot is a very famous website where you can actually add SSL certificates for free. Now if you are using an nginx server, you can easily do that. So you can choose your software, and you can actually, let's say, running it on Ubuntu. So that will redirect you to a particular website where you can see how you can actually install it. So it's pretty simple, and this is a very useful website to add SSL certificates. The next thing that I wanted to show you is API cache, since we have already mentioned that. So inside npm we do have API cache, and that is a very simplified version of caching responses, and it works on the principle that you can cache response for one particular endpoint for a specific duration. So if you want to cache the response to this endpoint for 5 minutes, this is how easy as it goes. You just import it, and then you have a variable that is API cache.middleware, and then you can directly cache a response. So you can cache all routes, or you can do it for one particular route, or you can even make use of Redis, which I've already spoken about. And finally, I wanted to show you a real life example of API versioning. So if we go to, let's say, Twitter developers, if I click on this, so we do have basically the Twitter API here. Maybe I'll just choose Twitter API. So here what you can see is inside Twitter API we have you have the Twitter API version 2 is here. So if you go here, you see that they have all this version 2 thing that they are trying to talk about what's new and all. But they also have a version 1.1 which was there previously. They even have a version standard and version premium. So you can see that for a large company who is trying to maintain their APIs, they do go ahead with API versioning because that's very essential for their clients or for developers using this in this particular case. So back in our VS Code, our endpoint should not look like this, but instead for each of these endpoints, we can add something like slash API slash version 1. So the reason why I'm adding slash API slash version 1 is because let's say you're actually trying to show some HTML or some front end with the same URL. So a slash API URL will ensure that when you're trying to send a request, you're trying to send it to the slash API endpoint and not the basically the template endpoint. So that's how our final APIs can look now. So that's all about all the good practices that you can take care of. Let's go ahead and conclude this video now. So I hope I changed a few lives today. I'm just kidding. But basically, I've seen a lot of backend developers out there, and they don't follow these good practices. They build APIs which are very hard to maintain and use. So I hope these tips, those 9 points, have actually given you a good insight about how to build APIs like a pro. So I really hope your next project will be great. And coming back from that, you can have a look at this blog I built. Basically, I wrote a couple of days ago, which also includes some of the architectural constraints that I was talking about, and basically not only scalability and cacheability and statelessness, we also need to ensure a few other things that which I have mentioned in much more detail here. So make sure to go ahead and give it a read. It has already a couple of like a lot of likes and reads, so I'm sure you'll find it interesting as well. So that's it for this video. Thank you for watching. Make sure to like, share and subscribe. And I have not been active on YouTube for a long time, but I am back here again, and I'll be sharing videos regularly. So all those people who have been commenting and opening issues, I'll be looking into that and I'll be resolving those as soon as possible. Thank you again for watching, and I'll see you in the next one.